Сейчас готовим лабораторию. Сегодня у нас выпал крутой снег. И готовим лабораторию для того, чтобы заниматься экспериментами, заниматься электротранспортом. Сейчас покажу. Это наши мотор-колеса. Видео, в которых мы показываем наш быт, это связано с тем, что на нас смотрят партнеры, инвестора, коллеги, и они смотрят, как мы развиваемся от того. Еще что хотела сказать. Дело в том, что те эксперименты, которые попутно, пока мы переезжали сюда в лабораторию, попутно у меня коллега в Москве делал эксперименты, да, и похоже на то, что у нас был выявлен некий гироскопический эффект. И вот этот эффект был описан такими намеками у товарища Серла, у Хендершота и в том числе у Флойд Свита в литературе Тома Бирдена. И для того, чтобы освежить свою память и пересмотреть или переосознать, чем занимались ребята, да, поскольку похоже на то, что наш концепт рабочий, а задача какая? Сейчас у нас человек из академии, который работает, у него есть определенная база в виде САПа, которая сможет произвести математические модели того, что мы обнаружили, чтобы еще раз сделать некоторые эксперименты и подтвердить, что мы кое-что обнаружили сверхединичное. Так что приятного просмотра. Том Бирден. Секреты Флойда Свита. Шерман Окс, Калифорния, апрель-май 1987 года. Сейчас мы имеем оборудование для демонстрации, сигнал, который уходит напрямую из нашего рабочего вакуум-триод усилителя. Сейчас мы видим вентилятор, который работает. Мы ощущаем приятный бриз. Мы видим, что это вполне юзабельная мощность, реально. Если мы повернемся, мы увидим 5 100-ваттных лампочек. Это обычные, вполне ярко светящиеся 5 100-ваттных лампочек, которые потребляют 500 ватт реальной мощности. Мы видим набор всяких инструментов измерительных, который может измерять усиление нашего вакуумного триода. Но если мы вернемся опять к этим 500-ваттным лампочкам, мы видим, что это мы имеем сейчас 60 нагрузку, которая работает на частоте 60 Гц. Это вполне конвертируемая негативная энергия, которая работает на 60 Гц. Это негативная энергия, которая продюсируется, которая может освещать нашу резистивную нагрузку, как это мы делаем в обычных парках, с такой же яркостью. И мы видим вполне реальный свет. И наша энергия продолжает работать, быть в негативной форме. Но в отличие от основного оборудования, оно остается прохладной, а не горячей. Это та энергия, которая вполне работает, конвертируется как обычная позитивная энергия. 500 Вт, полкиловатта стандартной нагрузки. Мы видим сейчас обычные переменного тока вентилятор. Если мы вернемся опять к нагрузке. И сейчас бы я хотел бы показать оборудование для измерения. И мы сейчас видим оборудование, которое показывает, тот сигнал, который идет у нас на сетку наших приборов. Мы сейчас имеем вольтметр. И показать, что реально измеряет этот вольтметр. Мы показываем, что это порядка осциллирующая, ну, аппроксимированно, это буквально такие 10 вольт. 10 вольт из нашего источника питания, который идет на сетку нашего прибора. Вакуум-триода. Мы сейчас видим amperage, мы сейчас видим ток, и этот ток равен 31,2 микроампера. Это актуальный 31,2 замер, который стоит на мультиметре, который стоит в пределах микроампер. Аппроксимирован это 10 вольт, то есть мы буквально, если прокалькулируем, то мы получим порядка меньше, чем 1 милливатт мощности, который поступает на вход. То, что идет на раскрутку нашего вентилятора и зажигает 5 100-ваттных лампочек. Сейчас я хотел показать вам еще дополнительное измерительное оборудование. Это несколько инструментов. Сейчас я попытаюсь сделать хороший фокус. И сейчас это вольтметр, который показывает выход порядка 110 вольт на выходе, который выходит из нашего вакуум-триод усилителя. Следующий метр это ваттметр. Это показывает порядка от половину 1 киловатта мощности, который порядка это тот измеритель мощности, который показывает реальную мощность. И сейчас мы видим, и мы хотим показать то, что происходит на резистивной нагрузке. И сейчас мы видим амперметр. Это вполне точно. Мы имеем на выходе порядка 4.6 4,7 ампера на выходе. Это тот ток, который идет с выхода нашего устройства. И это та энергия, которая идет из вакуума. Несмотря на то, что вся эта мощность, которая поступает, это буквально меньше 1 милливатта. Мы имеем 500 ватт реальной нагрузки, мы имеем вентилятор и все на свете. Это вполне реальная мощность. Но я дальше не вижу смысла переводить. Ну, он говорит о том, что здесь нету мерцаний, шума, каких-то негативных таких процессов. И все, что это все идет из вот этого коробочка, который стоит там, маленький коробок, который выдает эту мощность, который выдает 400-500 ватт, потребляя всего порядка 1 милливатта на входе.
Okay, now for this second demonstration, here we have our 120 volt fan again, rotating finely, stirring up a breeze. Right behind that you see a 24 volt DC motor. In front of that there is a little bit of a rectifier, a little box here. See if I can get my finger here. This is a rectifier. This is a transformer, dropping the AC power down to the 24 volts. And you can see there are two 12 volt lamps in series, brightly lit, showing you that yes indeed we have the full 24 volts. We're showing that this power can be transformed and can be rectified just exactly like normal positive power, except again the power is very cool in the actual lines and feeder circuits. Only in the actual resistive load do you have translation into normal power. But it can be run through a transformer and stepped down or stepped up. It can be rectified, and we can handle the power just indeed as we do normal power. And you see again at the same time we have 4 of those lamps now lit, and so we have another 400 watts resistive load going here at the same time. And if we close up on our little meter here, we'll see that now we're drawing only 29.2, if we get the glare out of there, 29.2 microamperes. 29.2 microamperes. We're still drawing about 10 volts, oscillating between 9.5 and 10 volts to the input of the grid of the vacuum triode, which is that little box right there behind the brightly lit 100 watt bulbs, now in the lower left of your screen. Again, 4 brilliantly lit, ordinary 100 watt lamps, household lamps. You can see here the 24 volt DC motor. You can see the transformer stepping down the voltage, the 2 12 volt lamps in series, so that we have effectively a 24 volt, the resistance for 24 volts applied across them. And in front of that then we are rectifying this power to furnish DC power to the DC motor. And so what this demonstration does is that with very little change to the input to the vacuum triode, we can provide a power which is practical. There's plenty of it. It's a very great power gain. It can be transmitted along lines without any heating. It can be rectified. It can be we can use a transformer to step it up or step it down. It's a very practical, very straightforward type of power to use, even though we're using negative energy in the lines. And the characteristic, when you switch suddenly power loads of negative energy, you do not have the big flashing and arcing, because that's a positive energy effect. The arcing effect on these is reversed. In other words, it's a cold arc, an arc of cold, so you don't see all of that stuff and you don't burn out the circuits and all that. You can switch the load suddenly very easily with normal switches. And so this is a very practical power. You can see again the 120 volt fan. You can see here a normal flat pancake type of 24 volt DC motor. You can see 2 12 volt lamps brilliantly lit. You see the rectifier that rectifies the current for the 24 volt DC motor. You can see we're coming through a step-down transformer from the 120 volt negative power line, and you can see we're still providing 400 watts of power in the lamps, and of course there wouldn't be any problem with turning the other lamp on. And you have seen, of course, that we're still drawing less than 1/3 of a milliwatt. We're drawing now 29.3 microamperes of current, and we're still sitting at about 10 volts on the grid. 10 volts, 29.3 microamps, the input to the grid of the triode, and you can see 400 watts of power here, a step-down transformer being operated, a pancake motor being operated, and a 120 volt fan being operated, all from less than 1/3 of a milliwatt of power. The rest of that power is coming out of the surging energy of the vacuum, and this little box that you see right here, solid state, no moving parts, is the vacuum triode that's doing this very practical and historical work here on April the 30th, 1987. And now we're focused on the actual little oscillator that's providing that input power. This is a Hewlett-Packard audio oscillator model 201CR. The maximum power this oscillator can put out is only 3 watts when it's at full peak power.
600 ohms.
And it's going out into 600 ohms.
And that would be 45 volts if you wanted to use 45. I'll use 10 volts.
The maximum voltage that this little oscillator can put out is 45 volts. However, as you can see, we're only using 10 volts, as you can see right here on the scale. So we're using 10 volts of power to the grid, voltage to the grid. Right now we have 29.3 very stable microamperes on the grid, so we still have less than 1/3 of a milliwatt of power on the grid. And from that we're pulling out of the vacuum, from cathode to plate, we are gating and controlling well over 400 watts of power. You can see the 4 100-watt bulbs brilliantly lit, and when I get off to the side you'll see just how brilliant they are when the CD readjusts. You see that we're stepping it down through the transformer, lighting the two 12-volt bulbs, going through a rectifier, driving a DC motor which runs fine off negative power, likes it real well, and then the 120 volt negative power is going to the 120 volt fan, which again likes it very well indeed. And so negative power, negative energy taken from the vacuum, is very useful and very practical power. This power can be put into production, can be developed into, for example, a reasonable home power unit, say of 15 kW, and you can see that this box, which we showed you a while ago with 500 watts on it, doesn't represent too much of a step-up problem. We're not dealing with very much a magnitude step-up problem. And so our scale-up problem should not be bad at all. I will mention that the little box in the back, the solid state vacuum triode, see if I can get my hand on this. You can see my hand on it. It is not hot. It's solid, solid state, no moving parts, no vibrations, absolutely rock steady and eminently practical. It is not expensive. Ordinary machining, ordinary parts, ordinary type construction can easily build this kind of a power device. As we said, the closest nomenclature for this device is a solid state vacuum triode. Nature itself is providing the river of current that's flowing from a special cathode to a special plate. And we are only putting in a very small control or gating signal to the grid to gate all the other power that you see being consumed right here. This power can be transmitted, it can be transformed, it can be rectified, it runs motors, it runs resistive loads, and it's a very eminently practical type of electrical power, very safe power, and a very clean power that's waiting right now for development and marketing. The incredible and historic vacuum triode. Okay, here we are again with the equipment shut down. We'll give you a short tour through what is connected and the major types of meters that we have connected so that measurements can be ongoing dynamically. First of all, behind this card, the little box that you see there is the vacuum triode, invented by Mr. Sparky Sweet, the incredible vacuum triode. Now, we've placed over the triode some small strips of metal so that you'll be able to see parts of the pattern of the magnetic fields surrounding the vacuum triode. And as we come back away from the triode, you see we have a load, which is a bank of 5 100-watt lamps. Can be connected to the 120 volt AC output load, 60 hertz. These are ordinary, common household lamps, resistive load. We have various meters. You see the frequency meter measuring the output of the vacuum triode, and you'll find that that's a very rock stable 60 hertz. Here are some lines. This is the input line right here to the vacuum triode grid. Nominally 10 volts RMS coming into the grid, 60 hertz, and as you will later see, very, very low amperage will be measured on the microammeter that measures the amperage going into the grid input. So it'll be 10 volts plus whatever this instrument measures. The next instrument here is the voltmeter itself that measures the grid input. And on this one we'll see the 10 volt input. The input signal itself is coming from an audio oscillator, which is a sine wave oscillator. It has a maximum output of 3 watts. That's all you can possibly get out of it. 45 volts into a 600 ohm load. That is what we're using for the input, and as you will see, there will be far less than that 3 watts going into the vacuum triode. Then here are the triode output cables going to the instrumentation, and then around behind the back to the load, to the lamps. We will be feeding a 1 kilovolt 1 kilovolt ampere 120 volt kVA 120 volt transformer, has dual 24 volt secondary. The loads will be 2 12 volt lamps in series, plus a rectifier, plus a 24 volt DC motor. Here is the rectifier right here, coming from the output transformer, with the 2 lamps in series across the 24 volt output of the rectifier, and with a 24 volt DC pancake motor, 1/8 horsepower, 2000 RPM, which will be energized. Here you see a voltmeter which reads the voltage on the rectifier output, and then we will have a standard 120 volt AC fan load also connected to the output of the vacuum triode. Coming on back around now to finish the instruments, we see a bank of instruments here. We have first of all a voltmeter that reads the voltage of the output of the triode. Then we have a kilowatt meter that measures the actual power output of the vacuum triode. We take a look at the phase. You'll see that that's really single phase current and everything's in phase. Then the amperes being put out, or the current being put out into the load by the vacuum triode. And finally, coming around here, we have an oscilloscope which will be set up across the output of the vacuum triode so that you can look at the 60 Hertz output waveform. We will show you the waveform on the scope. That completes the primary instrumentation, with the exception of the frequency counter here, where we actually show that it really is a 60 Hertz frequency output. And so Mr. Sweet will now turn on and energize the equipment, and we'll take you through another tour.
Now turn on the oscillator.
Okay, we're now turning on the oscillator. And we just heard the 24 volt DC motor start up. The two 24 volt lamps are illuminated, showing you that we're furnishing power to that transformer, stepping it down to 24 volts, going through the rectifier, lighting the lamps and running the DC motor. At the same time, before we step it down, the 120 volt power is being furnished to the 120 volt AC fan, and as you can see, the fan is blowing up a nice pleasant breeze here on this very warm evening. By the way, this is May the 16th, 1987, at the home of the inventor, Mr. Sparky Sweet. And from the lamps, we want to call attention to a direct ray which is invisible to the eye, but is visible to the tube of the CCD solid state part of this camera. You'll see a very straight beam of some kind associated with each of the lamps. We're still investigating that beam. Okay, the equipment is now energized and ready to be connected. Let's take a look at the output waveform. We can get down at the right level, and as you can see, we have a very good sine wave in the 120 volt AC output from the plate of the vacuum triode. A very nice sine wave indeed. And as you can see, when we turn to the frequency meter, we'll take a look here, and you'll see that we keep counting the frequency, and it's right on 60 Hertz. Right dead on 60 Hertz. You can see now that the power we are actually furnishing to the grid, this is the voltage. It's about 10 volts. It's oscillating between about 9.5 and 10. And on the microammeter, these are microamps. Right now we are furnishing 7.9 microamperes, and yet we're running two motors and lighting two lamps. You want to energize the other lamps? Okay, we'll look first now at the bank of meters, and we will see that for the output voltage, we've made a very careful adjustment, and it's right on 120 volts. Right on the button, 120 volts in the output, AC. This is the watt meter. I can't get a good focus on that, so I'll read it for you. Dividing it by 2, we're putting out right now about 140, 145 watts of power. The power factor, of course, is 1. Amperes we're actually putting out is about about 1.5, let me back up, 1.25 amperes of power being output. So we're actually putting out 240 watts right at it now, about 240 watts, and yet we're only putting in 10 volts and 7.9 microamperes. 10 volts, 7.9 microamperes. So the total input is a tiny bit less than 80 microwatts. We'll now energize the main lamps simply by connecting them into the load, screwing them in. There's the first 100 watt bulb which goes in. Here's another one, and here's another one, and here's another one. So we've kept the AC motor going, we've kept the DC motor and the DC lamps lit. We have 400 watt bulbs now being powered, and when I come off of this you can see they are brilliantly powered. When the camera is on the bulbs, the CCD steps the lens down so that we can actually get a picture. So we're producing now well over 400 watts. And in fact, if we come in on the watt meter right here, let's take a reading. We're producing 400 and some 80 watts. And as you can see from the meters here, at 10 volts and now 25.1 microamperes, we're putting in only 251 microwatts. 251 microwatts and about 480 watts out. So as you can see, we have quite a power factor gain. As a matter of fact, the gain right now is approaching 1,500,000. For each nominal watt of power input, one would get a nominal 1.5 megawatts output in a bank of such devices. This is May the 16th, 1987, at the home of the inventor, Mr. Floyd Sparky Sweet, and this is the incredible vacuum triode which organizes and gates energy directly from the vacuum itself, producing usable, practical power. So they really never changed anything, did they?
You say, oh, I got to design a big transformer, and he used to call the cucumber. But that's not an efficient.
I know. Well, let's see now.
You want a light on that, or you want the thing working?
Yeah, I need more light if I can get it, but...
Why the hell am I going to get it?
No, that's all right. I'll take it like that. What I need you to do is explain what we're looking at here. And
Want me to turn it on?
yeah, and I'll we're at the home of Mr. Sparky Sweet. This is 15 May.
Ну, здесь сейчас мы смотрим, как Floyd Sparky Sweet у нас показывает здесь процесс, как он приводит в кондишн свои магниты, которые используются в его вакуумном трионе, который создает некий накачивающий памп волны. Вы видите здесь большую катушку. Пытаюсь навести фокус. Это large, большая катушка. Внутри большая катушка. Мы здесь показываем, что мы здесь ничего пока не увидим. Здесь это все намотано на трубе, которая применяется Вот это провод, который был использован.
Number 15 wire sparking.
15 wire with a ECR of approximately 4 ohms of 20 volts.
Okay. About a 0.4 ohm impedance. Number 15 wire, a whole spool of it, is sitting inside the large conditioning coil down on the bottom.
Это
Right here we see
не говорит про
the
запровод.
SCR as part of the circuitry. There's a light bulb that gives him
Это мы видим
indication
лампочку.
of
Судя по
voltage
всему, это стоит у
across the
них.
capacitor. Here you
Это
see he's
лампа, которая
reduced
идет на
conditioning circuit to using only one capacitor. What's the capacitance of that?
This is
конденсатор, который
1600 microfarad.
It's a 1600
Microfarad.
microfarad capacitor,
250 volts.
250 volts,
60 тысяч микрофарад,
AC working voltage,
DC.
DC working voltage.
AC его
And he
DC
has a
working
very
voltage.
trigger arrangement set up and a potentiometer to adjust the circuitry, which he's now doing. As you'll see
Это
on the
мы
right above.
тиристорное все это дело. Нагрузка, которая, в общем, задача через эту нагрузку закачать
There is the capacitor
наш конденсатор до определенного напряжения.
tuning coil or conditioning coil to the coil on the bottom.
Coil in the bottom is driven by wave thick oscillator.
He has a wave-tech oscillator driving the coil
Здесь
inside
имеют
the bottom
волны, которые осциллируются.
through a 100-watt amplifier.
This determines the natural frequency of the molecular structure.
Они
That's the one
подключены
that you
через
press in there,
усилитель.
right? When we open the gate in the molecular structure of the domains, whatever
Это то, что
frequency we
молекулярно.
press with that inside bottom coil is the frequency that's
Это та
put into
частота,
the
которая-
magnet as a memory. In other words,
Это та частота, которая попадает на наш магнит.
the actual frequency of the pump wave, you might say
Это та частота, которая... Это частота, которая идет на наш привод.
By analogy, that's what's
И
established
это то,
to
что
make the magnet
осциллирует
travel.
и, в общем-то, кондиционирует сам магнит.
And the gate here is opened by it's pulsating
Я даю не совсем точный перевод, но пытаюсь отразить суть, самую главную.
capacitor discharge system, which is
Конденсатор разряжается на эту систему.
There's a capacitive discharge system attached to the large coil. It's being triggered by the variac, and as Sparky is pointing out, that is going
Он разряжается через тиристор.
this sets the time constant.
right. This sets the time constant of that, and that's going to determine the gate opening in the triode.
Which is
Это то, что пытается открыть некие магнитные ворота, которые работают на нашем вакуумном триоде.
of course the resistance of the coil and passes faster in farads. The resistance of the coil in ohms. And of course the time will be in seconds.
XBL of the
Не
large
обсуждаем.
coil is in ohms, and the capacitance is in farads, and of course the time is in seconds.
Катушка в омах, конденсатор в фарадах.
Which in this experimental setup, this particular magnet is found to be approximately 10 or 11 hertz, right?
In this magnet,
В этом
the rhythmic
магните
frequency of that magnet
резонансная
can be shown to
частота,
be in the vicinity of 11 hertz. Now each magnet will vary a little bit,
которая показывает,
and you must find the actual frequency for each individual magnet.
мы должны найти
But it's
найти
around
частоту, которая будет
11 hertz
резонировать на
beside the
60 Гц.
magnets we're using right now in the demonstration device.
Мы это все дело будет.
That's determined by
Это та частота резонансная, которая присутствует в магните, которая демонстрируется в нашем VTA приборе.
Okay, here we have placed one of the magnets
Здесь мы видим
on top of
один
the
магнит
wall,
Maybe I can get that to move.
на внешней.
and we're tuning the driver frequency.
Мы сейчас настраиваем и драйвируем нашу частоту.
This is on the inside coil we're driving now.
60 Гц. А,
And
нет,
when you
сейчас
get
эта
down
штука
to
резонирует на частоте
the
12
resonant frequency
Гц.
of the magnet, you will see the lamination that's been placed on top of the magnet start to vibrate. You'll see it shake and oscillate a little bit, just at the frequency that is the resonant frequency of the magnet. Do a little adjustment.
Now you're making adjustment.
И дополнительное подключение. Сейчас
This is
подключается
the
усилитель.
amplifier. He's tuning the amplifier voltage.
Oh, I unplugged.
Это тюнинг amplifier voltage.
Plug missing here.
Тот усилитель, который создает тюнингует, настраивает наш магнит.
And with me here this evening is Mr. John Bedini.
А это мы видим товарища Джона Бедини. В общем, этот Sparky что-то там сам с собой разговаривает. Что-то там пытается подключить, и чтобы...
Oh, wait a minute. took the oscillator out.
Yeah. Okay, now it's going.
О, пошел процесс настройки.
See if we can get that going there.
See if we can get it adjusted right on the resonant frequency.
Сейчас смотрим резонансную частоту.
A little lamination.
Небольшая иллюминация.
Good one. We'll get it just right.
Shut that down a second. This one. Wish I could see this dial. What do you want? Oh, wonderful.
We're getting it set up now for the right resonance range. And that's a sine wave frequency going to this inside coil.
Это sine wave, это синусоидальная частота.
And now you can see the magnet should also be aligned with the Earth.
Huh? What is it you want?
The long part of the magnet should also be generally aligned with the Earth's magnetic field for best results.
Things that I can't see the size. I can't see where 11 or somewhere was around 11 hertz before. I can't see it.
Right?
Let's see what
Пытается запустить нам свои эти приборы.
Is that 11?
Yeah.
Trying to go? Well, that frequency seems to be too high. Where are you?
There it is, Spark. It's very lively.
The magnet is now beginning to resonate. We'll see it just when we cross it right on there. It's a very small.
Сейчас только начинает резонировать магнит.
Frequency.
I can tell right away. Yeah, that's, here, see this one? That may be a good indicator for you. You know? Just hold it here, see? Square.
Yeah,
Hold
I
it
know
with
about-
this
I
hand.
know about this one.
Yeah, but then you can set this and you can feel it. Yeah,
There it is.
there it is. Right? Yeah. You want a resonance.
Что-то пытается срезонировать.
There.
Move it?
There it
Really
is.
is. That thing's really moving.
Now the magnet is in resonance, and so we have the proper
Сейчас магнит в
frequency
резонансе.
to resonate the
About
magnet.
12 and a half.
This particular magnet is resonating at about 12
You were right
and a half
about
hertz.
this part. Each one's different.
Each magnet is a little bit different, even though
Let's see
they're
if
the
we can
same
get it
size.
going a lot better. No?
That's good.
No, it's really going there. Okay?
That's in good resonance now.
Сейчас это хороший резонанс.
Okay, now you want it absolutely in perfect resonance, right? There you go.
There's the
That's
best resonance
12
we
and
can
a-
get, and that's
Сейчас
fine.
хороший резонанс.
It's at 12 and a half hertz.
Right. There you go. Now you got both of them locked.
This one is at, this one is at 60 hertz.
And now we're putting the
Okay, now you go up with this one, right?
Yeah.
the 60 hertz. I'm sorry,
That's
Sparky.
good right there. If you go off just a little bit to the edge, see?
There we
The 60 hertz was
Here, I can hold it there.
go. Now we gotta bring this one up, okay?
with the magnet in resonance at its 12 and a half hertz
There
resonance.
you go.
Сейчас магнит в резонансе на 12 Гц.
Okay.
At 60 hertz,
Right.
which is
Но
being
мы должны это
applied to the
всё
large coil.
доводить до
Yeah,
60
now
Гц.
stop.
And there we are. You can see
Yeah,
the
yes, just
magnet in
wavering in
resonance.
between.
It should be.
Okay. You want to bring it down a little more?
В общем, они как-то отрывками говорят.
There
There
you
you go.
go. Well, now explain how the 60 hertz is,
Well, it's
the
not.
memory is in that magnet.
with the magnet at its natural resonance, which for this magnet is 12 and a half hertz.
See,
The
this
triggered
gets it-
circuit
locks
is
it right in.
putting in
You can feel it
spiked
there. Put your hand
signals
right here.
of 60 hertz through the large coil. Triggered
Он
into
дает
spikes.
спайк сигнал на
Certain
60
constant
Гц.
discharge determined by the capacitance and the resistance. And that impresses
На
the 60
конденсатор.
hertz
There you go.
into the magnet itself as a permanent memory. And so the magnet will
Это-
have locked in 60 hertz resonance impressed in it. When it is in its natural resonance, it has a natural window that's opening so the 60 hertz can be put into
Это создает некое нейтральное окно, если мы подключаем всю эту систему на 60 Гц, который изменяет
And once
доменные.
that's done, that
There,
magnet
60 hertz, you can't see it.
is conditioned for the 60 hertz condition.
То есть надо доводить это всю эту работу.
It is
Нужно
now conditioned for a 60 hertz current.
кондиционный процесс доводить до того момента, когда он начнет резонировать на 60 Гц.
Look at that.
Now let it sit there. So you just put it to the edge, see?
Yeah.
Oh, that thing's moving. You want to get it going faster?
That's real good right there. That's maximum.
Ну это сейчас хорошо, но это максимум.
13 hertz.
At 13 hertz,
Сейчас
we have
13.
maximum in this magnet. As you can see right here.
So it's
И
low.
30
Shown
Гц
the
это
first part
максимум.
of the conditioning process to condition each magnet
Сейчас мы
individually.
покажем condition процесс.
The
I see what
entire,
you say. You have to condition this,
the entire magnetic assembly must be conditioned.
and then you put the whole thing
And so,
И
as you can see,
Otherwise you won't know where you're at, wait.
in. No.
now
должны
you can
доводить
see,
этот
Spark
процесс
has assembled the two magnets over the aluminum box
кондиционирования.
that is the holder.
And this is in positive mode.
And the ends must be kept in the same direction they were in when they were conditioned before.
Attractive mode. Now we put this in
And
there.
they're in the attractive mode. They're then placed in the box onto the
мы включаем так, чтобы они на коротке
sitting down on the
там.
other coil, so they're
притягивались.
about in the center of the large coil.
И мы это все делаем, вставляем в центр нашей формирующей катушки.
With the box in that position, then the final conditioning process is ready.
Мы ищем conditioning процесс, это положение.
You can hear the chattering as the beat frequencies go. Pump waves are going.
И мы видим частоту, с которой трясутся там
All that
магниты.
remains to be done is to turn on the 10
Это и есть
hertz,
настройка.
10 volt, 60 hertz driver signal.
И это 10-вольтовый, 60-герцовый драйв
Now,
сигнал.
see, your driver signal is in the small coil this time, right?
Yeah, that's the small coil, 10 volts, and well, in the case of the one we have inside is the power to drive it is 3/4 of a milliwatt.
Right.
1/3 of a milliwatt. Right? And we don't change that no more, right?
You don't change any frequencies.
You don't change this thing here, right?
Everything stays the same after we get a good wiggle on the magnets.
Yeah, and you put the magnets down in there. Just leave it on.
Put this semi in there.
Put this whole semi in there, and then you hit it with the frequency, 60 hertz. 60 hertz
Boom, that's it.
is the memory is in there.
Yeah.
It stays there, right?
You don't touch anything.
Now to activate it, you need a signal of 10 volts into the.
Ну тут уже информация не очень такая существенная, поэтому
It's not shown here.
Right.
я отвечаю перевод.
10 volts at 27 to 30 microamperes
Right.
will drive 500 watts of power out.
Right.
So that's the conditioner.
You have to take and do it with the two magnets, you know.
Mhm.
You find out first what that.
Pole is.
No. You find out first what the frequency is, the natural frequency, the magnetic resonance frequency.
With the iron bar, yeah.
Find out what that is. Right. Now, I found on the other one that I just took the two magnets. They were bigger magnets than this, and I put them together. Put them together like that. Of course, now I got them together, I can't get my shirt out.
Slide them apart. There, sorry.
I took them like that, and I put them like that.
Okay, so you mark the ends
I
now.
mark the ends, so they go back together the same way.
Mhm.
Then I found what the frequency was. Now, what it'll do, it'll average out the goddamn frequency, the goddamn natural resonance of this one and that one.
Right.
It'll average it out, right? So what you read on here, right, is a basic, resonance, magnetic resonance of the magnetic domains, right? That's there. So you know what that is, right?
Mhm.
You don't do nothing but you know what it is.
Mhm.
So you take them off of there and you put them on this box. And you put the whole assembly down in there,
Right.
right?
But
Now,
with the.
don't change nothing. Leave it right at that frequency,
Mhm.
right?
Mhm.
Leave it at that frequency while it's down in there, okay? Then hit it with the 60 hertz. The 60 hertz will go in there and stays in there.
Right. And then you can shut the 60 hertz off, take it out.
Forget it. Now you keep the magnets the same as they are. Remember though that you did it with this kind of air gap. You put one on the top, one on the bottom, stuck them down in there.
Right.
But don't change this,
Right.
because this has to open it up while it's down in there, not when it's up on here. This man
That's
tells you
right.
where that frequency is. It has to open up the nucleus when it's down in there. In the middle, it has to be in the middle.
Right.
There's a maximum field strength in the middle. And you put them like that. And you just stick them in there. And I had a compass. I was oriented in the north-south position.
Right.
With the north pole.
Towards the north. Towards the south pole of the earth.
And
Right.
orient them with the magnetic
Right.
field of the earth.
That's what I did.
Okay.
I put it down in there like that. What? In the sun. All right. Now, this is on.
Right, so it's
Well,
rocking.
That's on.
Mhm.
Now
Bottom
you
coil
hit
is
it-
on.
Now you hit it with the frequency.
And that's
Now
it.
That's it.
That's it. You can load the coils and go.
Go.
Just hit the big coil with the frequency, right?
That's
Yeah.
it.
The pulse.
Yeah, and that's it. You know,
That's it.
Don't
At
touch
that
it.
point, the conditioning is finished, and you now have a permanent magnet vacuum triode, the incredible invention of Mr. Sparky Sweet. This is May the 15th, 1987, in the home of Mr. Sparky Sweet in Sherman Oaks, California.